Good evening, guys. This is Bharat, and welcome to the video series of Mission Gate 2022 Electrical Engineering. And in the previous lectures, we have seen how to know the questions that you can expect in gate examination through the syllabus that is given by gate authorities. So, what we are doing is we are covering every topic, and through every topic we are discussing what are the type of questions that you can expect in the upcoming gate examination that is going to be conducted in February 2022. So till now we have covered about we are discussing about analog electronics. So what we have covered till now is that is the basics of diodes, FETs, BJTs, and BJT biasing, stability factor, and the things where you can expect questions from, and also the equivalent circuit of hybrid pi equivalent circuit of BJT for tackling gain questions, and what are the parameters that you should remember and what are the parameters you need not remember, that all we have discussed in the previous lectures. So in this lecture we will continue from where we have stopped in the previous lecture, that is different configurations. So we have seen about single stage amplifiers, that is common collector, common emitter, and common base amplifiers. Now we will see about multi-stage amplifiers, and after that we will go into feedback networks, and after that we will look at timers and everything. So before going into all that, first a bit about myself. I am Bharat. I am IIT Bhubaneswar graduate. I have graduated in 2015 from electrical engineering, and in 2021 gate examination I have secured a rank of 46 all India wide, and in engineering services examination 2020 I scored a rank of 39 all India wide, and in gate 2016 where I have scored a rank of 337, I got into Indian Oil Corporation. Along with IOCL, I got selected into Power Grid Corporation and IASC as well, where I choose to work for IOC. And in 2019 in AP Transco examination, I have scored a rank of secured a rank of 39. So this is about myself, and this is our Telegram channel. Can join this channel to discuss doubts with educators. So the link is given in the link description below. So you can click on that link to join the channel. So, and this is All India mock test for GATE 2022 that is being conducted by Unacademy. This mock test is conducted on every Sunday. These tests are absolutely free. Till now 2 tests were completed, and the next test is going to be on 16th and 23rd, and the last one will be on Jan 30th. So the more participation in these examinations will lead to the more accurate assessment of your scores and your ranks and everything that you will be getting in these tests that are conducted by Unacademy. So you will get a real-time idea of what the exam pressure which is going to be which you will be facing in the final examination. So it is always good to take mock tests before gate examination. At least 4 to 5 tests you need to take. So if you haven't taken these mock tests till now, at least take these tests from next Sunday on. So that is you will be having a test on 16th Jan. So you can scan the QR code given to enroll for these tests, and from there on you can join these tests on every Sunday. So coming to Unacademy Plus, here you will be given live access to whatever classes that you have subscribed to. So, and also you'll be having weekly tests here. The live classes will be like if you belong to electrical engineering and you are subscribed to gate examination, then you'll have access to all classes that will come under gate electrical engineering topic, and vice versa. And the classes are very much structured. These courses are prepared by topmost educators on Unacademy, and you will be having access to crash courses. That is, if you have 1 or 2 months for the examination, then you can make good use of these crash courses. And rank improvement batches, these are for those who could not convert the exam, like who fell in front of the target by a short margin. they can make use of rank improvement batches, and you will have unlimited access to whatever is being whatever you have subscribed to. There is no limit on the time or number of times you can watch a particular lecture. So this is about Unacademy Plus. And now coming to Unacademy Iconic, here you will be having a personal coach who will be giving one-on-one guidance to you regarding examination, and you will have study planner, that is the study plan will be customized to you, and your performance will be tracked by a personal coach who is assigned to you. We'll be having dedicated doubt clearing educators, and the notes of every lecture will be specialized to you. We'll be having study booster sessions as well. This is about Unacademy Iconic. So whatever the features I have told you now, along with Unacademy Plus, you'll be getting all these with Unacademy Iconic. So coming to the subscription charges, so you'll need to pay 2,704 per month for a 12-month subscription of Unacademy Plus, and you need to pay just 1967 per month for 24-month subscription of Unacademy Plus. And at the time of checkout, use my code KBC10 for extra 10% discount. And now coming to Unacademy Iconic, you will need to pay 4,704 per month for 12-month subscription and 3,467 per month for 24 months for Unacademy Iconic subscription. So at the time of checkout, use my code KBC10 for extra 10% discount. So this is about subscription charges. As I have already told you earlier, this is Unacademy Iconic subscription. That is, you will be getting a live mentor. That is one-on-one mentor. So with whom you will be discussing your doubts with, and also you will get your concepts and doubts clarified by him. And also the course or the notes are specialized to you. It's not like you'll be given common notes. The notes will be personalized to each student who has taken Unacademy Iconic subscription. And coming to Unacademy special class, so along with this is again free classes. So this is more interactive than a YouTube session. The class will be more interactive, and the participation of students will give will give you what it is going to be in a live class, and also you will get your doubts cleared during the class. And this is more fun because there will be polls that will be conducted by the educators. So if you can respond to the poll, and you can check if your answer is correct or not. So, and also you can use raise a hand option. That is for getting your doubts clarified during the class in real time. And also you will be getting notifications, so that you are never going to miss any class. And at the end of a lecture, you will be getting lecture notes. So this is our special classes. So whatever topics I could not cover in YouTube classes, I will be covering in special classes. And link of next special class will be given in the description. Please join. Click on the link to join the class. So this is Unacademy Ask a Doubt, where if you have any doubts, or if you are stuck at some point while preparing, you can take a click of whatever doubt you have, and you can crop the picture and you post it on this forum, and you will be getting solutions in whatever language that you have ticked on. This is for better way of solving your doubts and getting your doubts solved in an easier and faster way. So now coming to the topic, what we are doing in this topic or in this video series is we are trying to cover the syllabus through questions. So we are going topic wise, so that you will have an idea of what questions you can expect from each topic. Unlike if you are discussing the subject as a whole, you will not get an idea of what topics or what questions will come from each topic. So we are going topic by topic. Till now we have covered about diode circuits and BJT and FET biasing and amplifiers. So we have left out some of the circuits, that is special circuits. So you have a Darling pair configuration. It is not especially mentioned in the in the syllabus, but there are chances that you might be asked a question about finding gain, output current gain, or overall current gain for a given configuration. But you need not worry much, because it will be given with some approximations only. Not every not you need not consider everything. You will be given some approximations, but you need to know how to calculate this gain, and the method that you need to use, so that you will arrive at the current gain, whatever is asked in the examination. So mostly the current gain will be beta 1 plus beta 2 plus beta 1 beta 2. Either you can remember the formula, or you can solve the problem. That is about Darlington pair. And coming to cascode, again you are looking at gain problem in cascoding amplifier as well. So you need not remember these circuits, you just need to know how to solve these circuits. As I have told you earlier, there are 2 to 3 different methods of approaching or modeling whatever BJT that is given to you. But if you know the relationship between these 3 types of parameters, that is H parameter and hybrid pi, and there is another model. So if you know about the relation between these 3 models, then you can answer the question, or otherwise you can convert whatever model that is given to you to the model that you know, and you can solve these problems. So this is about BJT amplifiers. And now coming to FET amplifiers, we have already seen about BJT biasing. I think we have skipped FET biasing. We'll go to FET biasing as well. So FET biasing is similar to BJT biasing. It's just you will need a circuit, that is whatever concepts you have in basic electrical circuits that you need to apply while solving these biasing problems. So what you will do is, first you need to know different modes of operations of FET, and after that you will get to know how to solve these problems and all. First thing is, you will know different types of amplifiers, that is different modes of operations of FET as amplifier. That is, one is common source, one is common gate, and another is common drain. So for each configuration you need to know how to solve the circuit for gain, that is taking all input DC values, you will make it 0, and then you will find out output voltage, and from there you will calculate the output gain. Again, you need not know about this formula and everything, you just need to know how to solve these problems. So if a small signal voltage gain is asked, first thing you need to know is at what current and what voltage the given amplifier is operating at. For that you need to do DC analysis first, and after doing this DC analysis, then you will get the quiescent the current and quiescent voltage, and from that you will get this transconductance formula, and from that you will get R naught. If this transconductance and R naught are given in the problem, then there is no problem. If they are not given in the problem statement, then you need to do DC analysis, and from that you will get transconductance, and from there you will solve for small signal output resistance, and then from there you will solve for small signal voltage gains. So the same process you will follow for common source and common gate as well. So since these problems are kind of complicated, you will be given these problems with some approximations and all, so things will be easier for you. And also look at the problem for bypass capacitor, if bypass capacitor is given in the problem or not. If bypass capacitor is given, then your DC analysis will differ. If bypass capacitor is not given, then your DC calculations will be different. So you need to look at the problem for these exceptions. That is, in this case, the exception is bypass capacitor. So as I told you earlier, basic thing is, first you have to do DC analysis. From the DC analysis, you will find out the operating points. from the operating points, that is from operating current and operating voltage, you will calculate transconductance and R naught, and from these two you will be calculating the gains. The same method you will follow for every problem of FET amplifiers. So common source and everything we have discussed, and these output resistances are not that important with respect to FET biasing, so you can leave those output resistance and all. Only current gain is important. Output resistances are not that important for the FETs, but they are important for BJTs. And more than that, you need not study anything, because they will all there are important for ECE students and also for electrical students who are taking ESC examination. But for electrical gate, this is not that important, and even the questions are very you don't see many questions being asked from this topic. So what we have seen is most important topics from BJT, and important areas where you can expect questions from BJT and FAT are biasing techniques. You have to see the operating points where the FAT is operating, and when it comes to BJT, it's about if the BJT is under saturation or cutoff or active mode. And after that, BJT has three different types of being configurations for being used as amplifier, that is common emitter, common collector and common base. So here comes the theory part. You should know what configuration will have unity gain, and what configuration will have more output resistance and less output resistance, more input resistance and less input resistance. And also you should know which configuration will have unity gains for current and unity gains for voltage, so that if any problem is given from this topic, at least you will be able to eliminate one or two options based on the gain that you are looking at. Say for common emitter amplifier, the gain should be higher than 1. So if in the two options you are having a gain almost equal to 1, then you can eliminate that option, because the gain will not be equal to 1 for common emitter configuration. And we have already seen what topics you should be preparing for FET amplifier. That is, for FET amplifier, you need to pay attention to the quiescent voltage and quiescent current, and from there you will be solving transconductance and output resistance, and from there you will be solving for output gains and all. So this is about amplifiers. And now coming to frequency response, again this involves heavy complex calculations, but you need not to do all that for gate examination. So you should know about basic low pass filters and basic high pass filters and how they operate. And if a circuit is given to you, you should be able to tell whether it is a low pass filter or high pass filter or band pass filter or band rejection filter or everything. This can be done by using a substitution formula. That is, you will substitute some of the frequencies, and then you will know if the given circuit is what type of filter. So that is one method of solving these problems. And there is some formula for multi-stage amplifier that you can get it by heart. And rest of the things, that is raise time and fall time, these are not important for gate examination. And one more thing which is important for gate is that is Miller's theorem. How you will apply Miller's theorem for given circuit. So in the problem you will not be asked to consider Miller effect, or you will not be asked to use Miller's theorem for solving the problem. Simply you will be given a circuit and you will be asked to find out input or output resistance, or output impedances, or output capacitances, or say inductances. So based on if this type of question will be is asked to you in the examination, then you can use Miller's theorem for solving the problem. It will not be explicitly asked. You should know it by the problem definition, what the problem is asking. So frequency response, the hybrid pi model is not important for gate examination. You can leave it like that, because till now there hasn't been any question that is asked from this topic for gate. so you can leave this topic. And differential amplifier, it is again not that important for gate electrical engineers. So basically it has one or two formulae. You can remember those formulae, and you can substitute the formula in if the problem is asked in the gate examination, because it involves complex calculations and complex solution of the circuit, which will be difficult for you to solve in the examination. So you just remember the formula for everything, and you can you need not bother about how to solve the circuit. So it's not that important for gate examination. But if common mode differential mode gain and common mode gains are given, you should be able to find out a common mode rejection ratio, what it is going to be. And FET differential amplifiers are also not that important for gate examination. So these are the topics which are more important for ECE students. And feedback amplifiers, this is again important for electrical engineers. That is, you need not go in depth about these topics, but you need to know what different definitions are. That is open loop gain and closed loop gain, and gain sensitivity, and what is the percentage change in feedback gain, and how the bandwidth changes for different types of amplifiers, how the noise changes for different types of amplifiers. These are the things you should know. And how the cutoff frequency changes if a feedback is employed in a circuit, that you should know. And apart from that, you also should know about sampling and sampling networks, and also mixing and sampling. So what by looking at the circuit, you should be able to tell if it is a series shunt series, or series or shunt amplifiers. These are different topologies. So there are some shortcuts for finding topologies. So these topologies, again, you will be asked for 1 mark. These don't have much prominence with respect to 2 mark questions. So one more thing is you will not be asked to solve for currents or voltages or current gains or voltage gains in gate examination with respect to feedback amplifiers. But the thing is, by looking at the circuit, you should be able to tell if it is if it is series or series shunt or shunt or shunt series amplifier, so that you will be able to solve for output resistances or input resistances. Because sometimes what they'll do is they'll be giving you the gain without feedback and also feedback factor, and you will be asked to find out resistance, output resistance with feedback. So resistance without feedback will be given to you, and these things will be given. So by looking at the circuit, you should be able to find out if the circuit is coming under what type of topology in the given 4 different topologies you have. So based on that, you are required to find out output resistance or input resistance, or voltage gains or current gains and all. So by looking at the circuit, you should be able to solve these things. You need not know about different configurations. You just need to know by looking at the circuit, based on the shortcuts we have, you should be able to find out if it is it belongs to what type of classification. And from the classification, you will be able to find out output resistances and input resistances with feedbacks. So this is about feedback topologies. This is important for 1 or 2 mark questions. And so this is about BJTs, FETs and feedback amplifiers. So now coming to op-amps. These op-amps are again important for electrical engineers. This every year we are looking at a 2 mark question or one mark question and 1 2 mark question from this topic. So it will be mostly about circuit, solving the circuit. You need not remember anything, any difficult things with respect to op-amps, but you should know about basic characteristics of op-amps. That is how basic approximations, that is current will not flow into op amp, and also whatever voltage you have at negative terminal, that you will be having at positive terminal as well. So there are slight DC characteristics, that is input bias current, input offset current, and input offset voltage. And also you'll be having compensating resistance and all. They are just basics. You just need to have a basic idea of what these terms are and how they are compensated, and it's not much important for gate examination. And the thing that is important for gate examination is slew rate, that you can find out based on the equation that is given for output voltage. So it is the maximum rate of change of output voltage, and it has basic formula. Sometimes you will be given equation for output voltage, and sometimes you will be given a graph for output voltage. So based on this, you are required to solve the problem for slew rate. So it's nothing but the rate of change of voltage. So uh, uh, based on the problem, you are required to solve this for slew rate. That is, as I told you, that is it will be having two different problems. One will be graphical method, and other is equation method. So it all depends on the type of problem that is given to you in the examination. So you have different things, that is inverting amplifier and non-inverting amplifier, and how to solve these amplifiers for gain. And sometimes you will be given cascading, that is two stages of op amps that are connected in series. So and other thing is there is one approximation. We are whatever approximation we are taking while solving the problems for op amps is we are taking infinite open loop gain. And look at the question for if it is taking open loop gain to infinity, or the open loop gain is finite. If it is finite, it will be given in the problem that the open loop gain is finite, uh, and the open loop gain is this much, that is 100 or 1000 or 10,000, that will be given to you, and based on that you need to find out the closed loop gain. So closed loop gain will decrease if the op amp is not ideal. So you should look at the problem, if open loop gain is given in the problem or not. If it is given, then you should consider that also. And and if in the problem it is given that the op amp is ideal, then you can make the gain of open loop gain of op amp to infinity, and you can solve using the approximations. And two basic things that you need to remember while solving op amp problems is, no current flows into the terminal of op amp, and V plus is equal to V minus. That is, voltage at positive terminal of op amp will be equal to voltage at negative terminal. So these are two things that you need to you need to remember while solving problems for op amps. And things will not change for inverting or non-inverting amplifier, because the basic principle is same, that is whatever voltage you are having at positive terminal, you will be having the same voltage at negative terminal as well, and the current will not flow into op amp. For an ideal op amp, these are the principles. So based on this, you will be able to solve the problems with respect to op amps. It's more about using your basic electric circuit methods for solving the problem. It's nothing more than that. And you will have different things such as summing amplifier, differential amplifier, and also you will have integrator, differentiator, whatever whatever name the op amp will carry, the basic thing that op amp does is same. And the basic principle of solving op amp is very simple, as I have told you earlier. That is one current thing and one voltage thing we have, and based on that you need to solve the problem. It's just that. And one more important type of amplifier we have here is instrumentation amplifier. you should know the important features of this instrumentation amplifier, because it might be asked for 1 mark in gate exam. So this is again important for gate exam. And the solution for this, or whatever output gain for this amplifier, is not important with respect to formula, because you can solve this at the time of examination, because all this needs is a simple DC analysis, and based on this DC analysis we can solve this problem. And one thing that you need to emphasize more is logarithmic amplifier, because this is the area where people tend to commit mistake while solving the problem. That is, a diode will be given in the feedback and you are asked to find out output current. So what we do is, we'll make the diode drop is equal to some constant, and then we are trying to solve the problem. But we have to take ideal diode current equation here, since it is a logarithmic amplifier. So if a diode is connected in the feedback, or if a BJT with consecutive terminals shorted is given in the exam, so then you should consider it to be a logarithmic amplifier, and make use of diode equation, that is ID is equal to IS into e power Vd by eta Vt minus 1. Don't take any approximation for current equation, that is, don't make this ID is equal to IS into e power Vd by eta Vt. Consider minus 1 term also. From that you can solve it for output voltage if it is asked in the exam, and the same thing you can use for BJT with collector base shorted. So that is another type of problem. And another type of amplifier you have is anti-log amplifier. That is, till now we have seen that diode is connected in the feedback. Now you can see that diode is connected in non-feedback, that is, at input terminal there will be diode with respect in addition to whatever voltage source you have. So this is another type of problem. And other one is a precision diode. This is again important because it is used as half-wave rectifier. You should know how to solve this, how to analyze these circuits, because these are again important for gate examination. So till now we have seen about DC analysis. From this precision diode we are looking at AC analysis. So you need to know how the diode operates. Here the diode will be ideal or non-ideal, that will be given to you in the exam. If the diode is ideal, you have one approach, and if the diode is non-ideal, then you have another approach. So you should be very good with these rectifiers, because there are instances where questions have been asked from this topic. So we have covered this op-amps as well. So op-amps is basically using your basic circuit analysis. Whatever techniques you have in the basic circuit analysis, you have to apply the same in solving op-amp problems as well. So only thing, there are two things where you have to be careful, 2 or 3 things where you have to be careful while solving op-amp problems. One is, if the given op-amp is non-ideal, or if it is having any open loop gain, then you have a different approach. And look at the question, if the op-amp given is ideal or non-ideal. And other thing is, you will have a diode that is connected in feedback. It will lead to logarithmic gain. The gain, you should not take diode to be a DC drop. And other thing is, op-amps being used as half-wave rectifiers and full-wave rectifiers, you need to know how the op-amp is operating as this different types of rectifiers, and you should not leave this topic for gate examination. This is important. And other important thing is oscillators. So what is the basic principle of oscillation? That is the gain of amplifier and the feedback, that is A into beta, it should be equal to 1, and it should be equal to 1 angle 0 or one angle 360, that is Barkhausen criteria. So only if this criteria is satisfied, then the given circuit can be used as oscillator. So there are different types of oscillators. So you need not remember any formula for these oscillators. You just need to know how to solve these circuits. So first you will solve the circuit in terms of gain, that is you will find out the gain of circuit, and another equation that will be based on a feedback. So if you have these two circuits, then you will be getting from the feedback circuit, you should know at what frequency the circuit will operate at. The circuit will operate from the feedback. What we'll do is we'll make feedback, the whatever angle that you are getting for feedback voltage, you make that angle to 0. If you make this angle to 0, so real part, the imaginary part, you will make it 0. Real part will have some value and imaginary part you will make it 0. If you make this imaginary part 0, then you will be getting frequency in terms of R, L and C. From that you will know the frequency at which the oscillator will be, the whatever circuit that is given to you will be operating as oscillator. So if you substitute this frequency value in amplitude, that is the real part of equation, you will be getting amplitude of the oscillation. If you take inverse of this amplitude, you will be getting beta, that is feedback factor of this oscillation. You need not remember any formula for this, just need to know how to solve this circuit. That is you will have two things, V feedback and V output. So by making applying KVL for output for different loops, we will be getting different things. So whatever voltage that you have, that voltage will be it should be real in nature. So we'll be making the imaginary part to be 0. From this we are getting the frequency of operation. From there, if you substitute it back in the output voltage formula, output voltage equation that you are getting while using KVL, so you'll be getting the gain of operation. So this is one thing. And you have different bridges, the names are different, but the operation or the way you should use your equations is same. You have different Colpitt's oscillator, and you have Hartley oscillator, you have crystal oscillators and all, but the thing is same. So basically you need to apply a KVL, and from the KVL you will get 2 or 3 equations. From those equations you make output voltage equation to be real. So imaginary part you make it to 0, and from that you will be getting frequency of operation. And if you substitute this frequency of operation back in whatever output voltage that you have gotten, so you will be getting gain of operation. So this is about oscillators. And then you have comparators. So I'll come back to these comparators, detectors and all in a while. So since we have less time, we'll discuss first about digital electronics, how to cover topics from digital electronics. And after covering all these topics, then we'll get back to these comparators and Smith trigger and VCOs and all, because these topics won't carry much weightage for gate examination. We'll discuss about these topics at last. But there is an exception that last year a question has been asked from Schmidt trigger, I guess, or some circuit where a frequency of operation is asked in the examination. Though it is simple to the way to find out this frequency of operation is simple, but you should know a prior idea of how to solve, then only you can solve in the examination. It's not like by looking at the circuit you can solve the problem at the first time in the gate examination. It will take some effort. So before that we will try to look at digital electronics. So here you have a basic Boolean algebra. And even before Boolean algebra, we have number systems in basic digital electronics. That is, we should know how to convert a number from one system to another system. That if the given number is in octal system or hexadecimal or binary, whatever it is given, you should be able to convert it to decimal. And if a number is given in a decimal system, you should be able to convert it into octal system. So this is the basic thing that you should know while going forward in digital electronics. So this conversion from one system to another system is very, very important. And this BCD code, access 3 code, these are not important for gate exam and even gray code and all. You need not know about these codes in depth, but a basics should be fine. You need not know about these conversions in depth. That is about converting decimal to access 3 code, or access 3 to decimal, or access 3 to BCD code, or decimal to different codes, 2421 code and all. But you should know a basic, that is what a BCD code does and what access 3 code does and what 2421 or 4421 code does. And also there is a gray code. You should know what is meant by gray code, what is the difference between gray code and binary code, that you should know. And you should know basic things like binary addition, binary subtraction, octal addition. They are just basic things. And important thing is ones complement and twos complement representation. That is it comes under sign magnitude. So how things change when you are doing twos complement representation, and what are the advantages of twos complement? These are just a basic math. If you are good at basic mathematics, then you should not be having any problem while solving these problems. So that is about basic number systems in digital electronics. And now comes Boolean algebra. So Boolean algebra is basically different logic operations. That is, you'll have AND gate, OR gate, NAND gate, NOR gate, XOR gate, and you have different laws for Boolean algebra. Of these laws, the most important law is De Morgan's theorem, and also transposition theorem, and also consensus theorem. So there are 2 to 3 different theorems. They are very much important. Basic theorems you already know, that is associative law and complementary law and all, but most important laws are De Morgan's theorem and consensus theorem. So these theorems will help you in minimization of the given Boolean function. That is, sometimes you will be given a Boolean function, you will be asked to minimize the given Boolean function, and you will be given 4 options to choose one from. So if you have if you are going to solve these problems, you should know all these theorems, how they are operating. This is one type of problem you might expect in the gate exam for 1 mark. And also you should know min terms and max terms, and different forms of representing the equation, that is sum of product and product of sums. Mostly the questions will be about sum of products, but people are kind of uncomfortable while solving the problems for product of sum. So product of sum you should have a fair idea of, because if the examiner wants to trouble you in the exam, in the gate exam, so he might use product of sum. You might be given options that like every option will be a product of sum, then you should be choosing one option from the given POS forms. So you should be good at product of sums as well. So another thing is, if a truth table, first thing is, if a truth table is given to you, you should be able to solve it for sum of product and product of sum in min terms. How you are going to represent it in minimum terms. And next thing is how you are going to draw truth table from a given statement. So if a statement is given to you, you should be able to draw the truth table, and from the truth table you should be able to solve for sum of product or product of sums. So if it is given in the problem that if the given input is a prime number, then the output is 1, or you might be given that the bulb glows when the input number is an even number. So for every even number the output will be 1, and for every odd number the output will be 0, or every prime number the output might be 1, and for every non numbers the output might be 0. So based on the given problem statement, you should be able to uh, draw the truth table. From the truth table you should be able to solve the problems. So what uh, helps you in solving these truth tables is a Carnot map. So Carnot map for 3 variables and 4 variables you should be comfortable in solving. So these Carnot maps will lead you to the output sum of products or product of sums, and also by you know uh, if you are omitting whatever common terms that you are having, so then you will be left with minimum terms. So should be good with a Carnot map to arrive at a solution which is having minimum terms. So you need not bother about five variable one. So if you are good at solving these Carnot maps for 3 variables and 4 variables, then it is good. And you should know how to solve for sum of product and product of sums as well. So other thing is, you have implicants, that is prime implicants and essential prime implicants. You should know the difference between these two, and sometimes you can expect the questions in the gate from you might be asked to find out the number of essential prime implicants for the given Carnot map. So that is another type of question that you can expect in the exam. So thing is, you should be solving more and more number of questions for Carnot maps, so that you won't have any problem while solving gate questions. So that is one thing. And now we look at logic circuits. So till now what we have discussed is conversion of any given system numbers from one given system to another system, and other thing is basic Boolean algebra, that is different class, and then a Carnot map, and then sum of product and product of sums, and prime implicants, essential prime implicants. So now we look at these different gates: AND gates, NAND gates, OR gates, and XOR gates, and everything. Basic thing is you should know how different gates function, and other thing is you should be able to whatever minimum whatever function that you are getting for a given problem, you should be able to implement that with NAND and NOR gates, because these two gates are universal gates. So you should be able to implement any truth function or any Boolean function with these two gates. So another question that you can expect is the minimum number of NAND gates or NOR gates required to establish a given function. So there is prescribed way to solve the questions for NAND and NOR gates. So this again requires extensive problem solving. So the more functions that you solve for implementation with NAND and NOR gates, the better you will be at these. So this is about universal gates. So the minimum number of NAND and NOR gates required for implementation of a given Boolean function, that is one type of question that you can expect in gate examination. So now coming to combinational circuits, here you have adders, that is half adders and full adder. So how a half adder behaves and how a full adder behaves, and how to implement these two functions, you should know. In the exam you won't be asked to know what is the expression for sum and carry in full adder, that you won't be asked. in the gate examination the questions are never straight, or never they'll be in standard format. So and moreover this half adder and full adder are easy. And the important thing is binary parallel adder, which will have carry propagation. So sometimes you will be asked to find out the delay, propagation delay, because since it is parallel adder, the carry will be going from rightmost element to left, and you will be having different carries. So you should be able to find out minimum propagation delay. And one more thing is look ahead carry adder. This is again important. So the output, that is the output for each carry equation, the expression for each carry you should know, and you can get it by heart. You can solve it in the gate examination as well, but it will take again much time for solving. And serial adder is not that important because it won't be having any timer delay, so it is not that important for gate examination. And similar to adders, you will have subtractors as well, but they are not that important for gate examination, and you can leave it. So another thing is how to convert one code to another code, that is binary, how a binary code can be converted to gray code, and how a gray code can be converted into binary code. These you should know how to convert these things, and you need not remember the output formula for these things, because in the exam you won't be asked questions directly. And next you have magnitude comparators, and this is again important. If the output is greater, if A is greater than B, then only output will be 1. If it is less than 1, if it is less than B, then the output will be 0, and different conditions will be given to you. This is again important. Just take a look at these things in your class notes, and then you are good to go. And most important thing from digital electronics is multiplexers. And from numerical question types, you can expect the total number of multiplexers required to realize a circuit that you can be asked. And basic thing is how you are implementing multiplexer as universal gates. That is one type of question you can expect in the gate examination. And how to implement different expressions, different Boolean expressions with a multiplexer. That is another type of question that you can expect in the gate examination. A 4x1 mux can implement a two variable function, and also a 3 variable function. How it is going to implement a 3 variable function is a bigger question. That is it involves some calculations and all. So this is more important for gate examination. That is how a 4x1 mux is, you can you can implement 3 variable functions with 4 cross 1 mux. And what is the total number of multiplexers that are required to to establish a certain circuit. That is another type of question that you can expect. And there are decoders. Again you should know the basic functionality of decoders and encoders, because any stock problems will not be asked in the gate examination, but if you know how these decoders work, then you will be good to solve the problems with respect to these decoders and demux as well. So thing is, you should know the definitions are how a multiplexer operators, an encoder and a decoder and a demux. How what are the differences between these two in with respect to the operation, that you should know. Because if you know about basic operation, then half of your problems are gone. Then there are more chances of you arriving at a proper and correct solution. How encoder operates and how decoder operates, and what is priority encoder and what is priority decoder, and you should know about all these things. So this is about multiplexers. And now coming to sequential logic circuits. This is again important for gate exam. So these sequential circuits are different from combinational circuits, and you will have latches and flip flops. So basic thing starts from SR latch. So this sequential circuit starts from SR latch only. We should know for what different inputs of SR the output will be the state of output. So if it is 0 0, output will be the same as that of previous state, and for different inputs of SR you will be having different outputs. So you will have different things, that is a latch is different from a flip flop. Should know the differences between these two, and if it is level triggered or edge triggered, that you should know as well. So excitation table for each flip flop is important, and after SR we are learning about JK, then T flip flop and D flip flop. So these are basic flip flops, and the conversion between among these flip flops you should know how to convert. Sometimes we are getting confused between the conversions, and we are committing mistakes while solving these problems. So basic conversions you should know, and also race around condition is important with respect to gate examination. So what causes race around condition, and it occurs in latches or flip flop, and what type of flip flop race around occurs, and what is the remedy or for race around condition, that is we'll use master slave flip flop. So what changes from normal flip flop to master slave flip flop, that is by looking at the given input you should be able to draw the output for master slave flip flop. So another thing is a common questions will be like a digital circuit will be given to you with n number of flip flops, and some gates will be given to you in between. So initial value of output will be given, and you should be you will be asked to find out number of pulses required to get some required output. Say if the flip flop is starting at 0 0 0, you might be asked to find out the number of clock pulses required to reach 1 1 0. So it will not be 6. So based on the circuit between the gate between the initial flip flops, you will be getting the final output. And as I told you earlier, uh, the state equations and the characteristic table for each flip flop is important. Truth table is different from characteristic table. These two tables are important while solving any problem with respect to the states. That is, a given input clock will be given, and you will be asked to find out the sequence of flip flops or number of cycles reached to required to reach a particular sequence. And as I told you earlier, these conversions are important with respect to flip flops, and applications wise it's not that important. So we have discussed about basic Boolean algebra, combination and sequential, and mux and demux. And in the next lecture we will discuss about A to D and D to A converters, and also different types of registers in digital electronics. And also coming to analog electronics, we will discuss about different timers, and whatever topics that we have left in analog electronics, that is VCOs and timers, sample and hold circuits and Schmitt triggers, we will look at in the next lecture. Thank you.